Recorded is rolling. It is Tuesday, February 13th. Have a lab for you guys today. Lab. So turntables are back. Before I get going too far, right? Do you want to do some multiple choice questions later this week? So try this a little bit different. I think let's have you guys do this on AP Classroom. Can you guys bring your laptops on Thursday for sure? Probably bring them every day, but definitely Thursday. Okay. Okay. All right. So turntable lab. And so got this turntable. There's a whole set of these back in the lab area. I'll have you guys back in the lab area. Right? There's a bunch of these little lab weights. Right? Set that on here, give this a spin, and the lab weight stays on the surface because, guys, what force is keeping it on the surface? Friction force, right? But if I keep spinning this faster, do you think at some point it's gonna fly off? Okay. Now, if you do that yourself, right? Then do you think you could maybe spin it faster, and then the moment that it flies off, maybe just use your finger to provide a force to overcome the friction force that would naturally slow it down, right? Just to keep it going at constant angular velocity. Can you guys do that? Maintain constant angular velocity, right? And then do you think if you maybe like had a stopwatch, you could somehow figure out what that angular velocity is, right? And what unit ideally would you measure angular velocity? Radians per second, right? Radians per second. How fast is it rotating? Radians per second, right? If you said something like RPM, revolutions per minute, that is also true, but maybe in a mathematical sense. If you're applying equations, you definitely want radians per second, right? And this Greek letter omega, right? So two tools you guys get to use today. This stopwatch is one of them. Also, what other tool do you think? How about roller to measure what is this radial distance from center? This one, somebody drew a little central dot here, which is really convenient, right? You go center mass, center, right? Like that right there might be, about 11 centimeters. I could call that 0.11 meters or something like that, right? All right, so your goal today is to figure out what is the coefficient of static friction between a lab weight and the surface, right? What is the coefficient of static friction? Okay? Just for some particular lab weight, right? If you wanted to switch out different lab weights, keep in mind that coefficient of friction is a material property. So these three different lab weights, well, I see three different materials. Got two different kinds of metal, got some kind of paint coat here. Right? So, but you don't need to do that. Just if you use one lab weight over and over, okay, so that should be fine. Just one lab weight, right? Oh, so here's a picture setup. If this was an FRQ and you're good at drawing, you want to dash off a picture, right? So a diagram setup might be helpful. Right? I'm gonna have you guys do one of these 5-part write-ups today, and then we'll score this tomorrow. So by the end of the class today, you guys should have this my first period class. There was plenty of time, so it should be all right, right? And then tomorrow we'll score this. I came up with a scoring rubric yesterday. I did a write-up myself, right? But it's kind of in line with what we've done so far. You guys have seen plenty of these so far. So I'll help you guys out a bit. So here's the 5 parts I want you guys to do. First part, question, and here's your question, right? What is the coefficient of static friction? That's mu sub s, right? Between the lab weight and the turntable surface, right? So that's it. That's all you're trying to find, right? Oh, measuring tools. So I'm listing 2 tools here. Yeah, a ruler and a stopwatch. Right? Now you might think, well, could I possibly need the balance or some kind of scale, triple beam balance to measure the mass? Right? How many guys think that the mass ends up canceling out by the end? You guys think the mass cancels out? Right? If you think it does, then maybe you're a step ahead. Also, the fact that there's a mass in grams that's stamped into each one of these. So maybe that could be like a given value. So for both those reasons, maybe you don't need any kind of tool to measure the mass. Right? Procedure, you're usually looking somewhere between 5 and 7 steps. When I wrote up my own last night, I have 6 steps. So you can just look in the ballpark. Right? One of your steps could be just to very briefly describe the setup. Right? Then I'm going to use what measuring tool to measure what variable. Right? Analysis. Now, analysis, you're either looking for equations to derive something or a graph, and usually some property of a graph, oftentimes the slope, right? I'm not going to have you guys do a graph for this one. I'm just looking for some kind of equation type derivation, right? And then conclusion, and make sure your conclusion answers the question. Right? Do you guys think you can figure this out by end class, right? And have the full 5-part write-up? So then, I'll walk around, make sure you guys are on track, being all right, and then tomorrow we'll go through and score your guys' 5-part write-up. And remember, definitely bring your laptop Thursday. So I'll have some AP classroom questions for you then. All right, everything you need back in the lab area.